Hi students, this is Mr. Yao. Today we're going to talk about 9.12, where we will learn the first time of trig identities. First, the definition of trig identities, or any kind of identity, is a statement of equality that is true for all values of a variable for which both sides of the equation are defined. So basically we're just proving an equation, left side actually equals the right hand side. So let's do a bit recall on SOHCAHTOA on how to represent these trig functions with a right triangle. So sine would be O opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then cosecant are just these first three flipped. So cosecant would be hypotenuse over opposite, secant would be hypotenuse over adjacent, and then cotangent would be adjacent over opposite. And then we have the first official group of trig identities, which is something we have also learned already, but now we're giving it an official name, reciprocal identities. That's basically saying cosecant and sine are reciprocals. So cosecant is 1 over sine, and sine is 1 over cosecant. Secant is 1 over cosine, so cosine is 1 over secant. Cotangent is 1 over tangent, and tangent is 1 over cotangent. Then the next group will need a little bit of work, something called quotient identities, and we're also going to, in the process, prove it. First, tangent. We know tangent is actually opposite over adjacent, so opposite over adjacent. Then you may notice opposite also appeared right here in sine, and adjacent appeared here in cosine. But also sine and cosine both share the hypotenuse. So I'm going to actually put them in that form. So I'm going to divide the top by a hypotenuse and the bottom by a hypotenuse. And then you will notice, well, since I did the same thing on the top and the bottom, it wouldn't change anything. But then you will notice the top is actually sine and the bottom is cosine. So tangent is actually sine theta over cosine theta. Then we're going to do the same thing with cotangent. Cotangent is right here, adjacent over opposite, so A over O. And same thing, I'm going to put them over H, so A over H and O over H. You will notice adjacent over hypotenuse is cosine, and the bottom is sine. So cotangent is cosine over sine. Now let's use these to do some simplification and proof. First, simplify. And when we say simplify, we mean put in terms of sine and cosine. So tangent, we need to rewrite it into sine theta over cosine theta. Then we see is multiplied by a cosine theta. If you don't know how to treat that, you can always put it over 1. So it's basically two fractions multiplying each other. The cosine cancels. That simplifies to be just sine theta. Number 2, I can rewrite cotangent to be cosine over sine. And then I'm going to still put the sine next to it. That means multiplication. And I'm going to put it over 1. The sine cancels. Just have cosine theta left. That's number 2. Number 3. Now we're going to officially start proving these. One pretty common way to prove is we're just going from left-hand side, equal, then make some more changes, equal, and then eventually going to equal right-hand side. So that's LHS stands for left-hand side, RHS stands for right-hand side. So I'm going to start with my left-hand side, which is cosine over sine, the whole thing over 1 over sine. These do require you to know about cotangent and cosecant. Then if you look at the fraction on the top and the bottom, you would notice they share the same denominator. That means I can get rid of it. And to get rid of a denominator, I'm going to multiply by an extra sine theta on the top and on the bottom. They cancel. So I have cosine theta over 1, which basically is cosine theta, which is the right-hand side. I got it right. That's number 3. Number 4. If you compare number 3 and number 4, you will notice something. In number 3, the fraction is on the left side. In number 4, the fraction is on the right side. And we typically treat the fraction side to be more complicated. So on 3, we started from the left side. However, on 4, we are going to start on the right hand. So the rule is, the underlining rule basically is we always start from the more complicated side and see where we can get. So the right hand side, I'm going to rewrite the top, which becomes sine theta over cosine theta, holding over the bottom, which is sine theta. Then you may notice, well, in the previous question, I have a fraction on the top and on the bottom. Not on this one. I only have a fraction on the top. Well, if you think about it, you can actually make up a fraction by putting it over 1. Now you have a fraction on the top and the bottom, and they have the same numerator. When they have the same denominator, we multiply it on the top and the bottom. This time they have the same numerator, so instead of actually multiplying, we are going to divide the top by a sine theta and divide the bottom by a sine theta. And in that case, the sine theta cancels, the sine theta cancels. Then you might be wondering, wait, after I cancel out the sine theta, what do I have left? On the top, even though you canceled it, you still have this fraction line and cosine is on the bottom of it. So you still have 1 over cosine theta left, and the whole thing over 1, which is just 1 over cosine theta. If you think about it, 1 over cosine theta is actually secant theta, which is the right-hand side. That means we got it right. That's number 4. Number 5. We are going to rewrite them again. So left-hand side seems more complicated than just 1 on the right-hand side. So sine theta over cosine theta, then times cosine theta over sine theta. Well, that's fraction multiplication, and since we have fractions, we can do some cross-canceling. Sine, sine just cancel, cosine, cosine just cancel. So we basically have 1 times 1, which is 1, and that is the right-hand side. We got it right. Next, number 6. I'm going to do the same thing. Tangent is sine over cosine times cosine times sine. I can put it over 1 so that I can cross cancel cosine, and I just have a sine and another sine left, which becomes sine theta squared. So we started from the left hand side, we got that, and that is the right hand side. And something you may notice is this 2, that's kind of in a different position as the exponent we have learned before. So here are 2 different ways to write sine squared, sine theta squared. One is we typically put the exponent between the sine and whatever angle it is. So I can have sine theta, I can have tangent, let's say tangent alpha, then I can still put like say cubed right there. We'll also put the exponent in the middle. Or another way is you put it the whole thing inside parentheses, then raised to the second power, or this tangent alpha to the third power. These are 2 different ways to write exponents for trig. Number 7. I'm going to rewrite the top. Secant is 1 over cosine, and cotangent is cosine over sine. And the whole thing is going to be over cosecant, which is 1 over sine. I can cross cancel the cosine. Then you may notice the top now becomes 1 over sine. And since the denominator is sine and sine, I'm just going to multiply by sine. Or since the top and the bottom are the same thing, you can just cancel them. So either way, sine will be gone. The whole thing is 1 over 1, which is 1. That is the right-hand side. We started from the left-hand side. That is number 7. Number 8. So by now, you may notice for all of these questions, you might have done things slightly different than me, which is totally fine. For these proofs, there are many different ways to do them, as long as you can have a backup reason of why you're doing a certain step, and then you can also derive the final conclusion to actually get to the right side, then you're fine. You can do it many different ways. Number 8, sine. Then I have tangent, which is sine over cosine. As for the bottom, so I start with left-hand side. As for the bottom, I have 1 plus 1 over cosine theta. If you look at the top, I can rewrite it into something else. So if I actually write this is something you may notice. So x plus like xy. If this is something you're being asked to simplify, you may actually do factoring. So you take out the x and then see what's left. Same thing here. Because you have sine and sine, I'm going to factor it out. But as soon as you factor the first part out, you still have a 1 left. Since you have factored out the sine from the top is going to become a 1, then you still have over cosine. The bottom is 1 plus 1 over cosine. And by that step, you may have noticed already, the top and the bottom are actually the same. So you only have sine theta left, which is the right-hand side. So we got it right. That is number 8. Next, I have sine theta squared plus cosine theta squared. This is called the Pythagorean Identities. It's not Pythagorean theorem, but it's related to Pythagorean theorem. So let's have a look. Sine, as we know in a right triangle, is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So when you square it, the whole thing is going to be opposite squared over hypotenuse squared, then plus adjacent squared over hypotenuse squared. Then you may notice they have the same denominator, so I can put them together. H squared on the bottom, the top will be opposite squared plus adjacent squared. If you look into a right triangle, let's say this is our theta, that's hypotenuse, that's opposite and adjacent. You may notice in a right triangle, by just Pythagorean theorem, opposite square plus adjacent square is actually hypotenuse squared. So it's going to be hypotenuse squared over hypotenuse squared, which is 1. So the identity is sine theta squared plus cosine theta squared is 1. Now let's look at how to use these examples to actually find some more trig functions. Number 9, you're given cosine theta is negative 2/3. We have done questions like this, like you are given, say, cosine is 2/3, you draw a triangle, that's 2, that's 3, and you need to find the other side to find the trig function. We have done things like that. But here, we can't exactly draw a negative distance, negative length. That's why we're going to use the identity to help us find the other trig functions. Sine theta squared plus cosine theta squared, cosine is negative 2/3, that's being squared, and equals 1. Keep going, sine theta squared, negative 2/3 squared is 4 over 9 equals 1. Then I'm going to subtract 4 over 9 on both sides. So I got sine theta squared equals 5 over 9. In order to get rid of the square, I'm going to square root both sides. And you can square root by square root in the top and the bottom, which square root of 9 is a 3. However, something you need to be careful with is we do have plus minus when we actually do square root. The last thing, the question is not done, is that theta is in the 3rd quadrant. You actually look at your unit circle inside 3rd quadrant. Sine is actually negative. Sine is negative. Which means in our final answer, we are only going to keep the negative, which is negative square root of 5 over 3. As for tangent, tangent is going to be sine over cosine. So it's going to be negative square root of 5 over 3 over negative 2 over 3. Since both fractions have 3 on the bottom, so I can cross them out, and the negative becomes positive. So I have square root of 5 over 2. And these are my final answer for the sine and tangent. Number 10. You're given sine, and let's put it in, negative 24 over 25 squared plus cosine theta squared equals 1. And that is going to be 576 over 625 plus cosine theta squared equals 1. So cosine theta squared equals, that's going to be 49 over 625. So square root both sides. Cosine theta is going to be plus minus square root of 49 is 7, square root of 625 is 25. We're not done. There's extra information. Theta is in 4th quadrant. And inside 4th quadrant, our cosine is negative, is positive. Because all students take calculus, so it's going to be positive. That means our cosine theta is actually going to be a positive 7/25. As for cotangent, cotangent is cosine over sine, so it's going to be 7/25 over negative 24/25. The 25 just crossed out, so you are going to end up having negative 7/24. That's how we actually use these to solve for the other functions. Now let's have a look at how to use the Pythagorean identity to prove. Number 11. We're going to rewrite tangent. So cosine squared stay there, and tangent squared is sine squared over cosine squared. Then we still multiply by a cosine squared. So cosine squared just cancels, and we got that. We started from the left hand side, and then we got cosine theta squared plus sine theta squared. That happens to be the Pythagorean identity, so it equals 1, which is the right hand side. So that means we got it right. Number 12. You look at it, that's basically 1 over secant and then squared. So what is 1 over secant? It is cosine squared. Next one is 1 over cosecant squared, and that's got to be sine squared. Sine squared plus sine squared, Pythagorean identity, it equals to 1, which is the right hand side. We got it right again. Number 12. Number 13. You first see cosine, and this is where we're going to do a little bit rewriting. We know sine theta squared plus cosine theta squared is 1. So I can also rewrite sine theta to be 1 minus cosine theta, or I can rewrite cosine theta to be 1 minus sine theta. I just move that to the other side. So cosine squared, that is going to be 1 minus sine squared over 1 minus sine theta. Now here's something you may have forgotten. If you look at the top, 1 is basically 1 square. So this is a perfect square minus a perfect square. We have learned if it's a square minus b square, we can factor it to be a plus b times a. That's something we have learned. So the top will actually become 1 plus sine theta times 1 minus sine theta, and the whole thing over 1 minus sine theta. So 1 minus sine theta cancels, so we only have 1 plus sine theta left, which is right hand side. So we just finished our proof. Number 14. Cosine, if you actually see, is 1 minus sine theta squared, then minus another sine theta squared. We started from the left hand side. That will become 1 minus, these two are the same, so they can be combined, which is 1 minus 2 sine theta squared. That happens to be right hand side. And we got it. That's number 14. Next, number 15. This is where things get complicated. So let's have a look. We have cosine theta plus 1 all over sine theta to the third power. As for the right hand side, we have cosecant theta over 1 minus cosine theta. For this one, if you just try to derive the left side, well, they're already all in sine and cosine. So there's not much we can actually do. But when you see this, when you see 1 minus cosine theta, that's something we can actually play with. So I'm going to start from the right hand side, which is cosecant theta over 1 minus cosine theta. And we have recalled, if we do 1 minus, if we have cosine theta squared, that's 1 minus sine theta squared. If we have sine theta squared, that equals to 1 minus cosine theta squared. And since they're perfect square, you can basically rewrite them as 1 plus sine theta and 1 minus sine theta. This is 1 plus cosine theta and 1 minus cosine theta. Well, I see I have a 1 minus cosine. Can I actually try to get to 1 minus cosine theta squared? Of course I can. I'm just going to multiply the top and the bottom. by 1 plus cosine theta. Because that's basically a 1, it wouldn't change anything. But for the bottom, I'm going to get 1 minus cosine theta squared. The top is 1 plus cosine theta times cosecant theta. The bottom is going to be 1 minus cosine theta squared is sine theta squared. As for the top, 1 plus cosine theta, and the cosecant is actually 1 over sine theta. And if you think about it, the top, that's a fraction, the sine is a denominator. This sine theta squared is the denominator of the whole thing. So basically, I have 1 plus cosine theta over sine theta squared times another 1 over sine theta, which happens to be 1 over cosine theta over sine theta cubed. And that is the left-hand side. So we just proved it. Last one, number 16. Cotangent is cosine theta over sine theta. Inside the parentheses, I have cosine theta over sine theta plus sine theta over cosine theta. And that's the left-hand side. I'm just going to move forward with that. So I have cosine theta, sine theta. As for the inside, I'm going to need to use a common denominator, which is basically these two put together. So it's got to be sine theta, cosine theta. If that's the case, I'm going to need to multiply the top and the bottom on the first one by a cosine theta, and multiply the top and the bottom on the second one by a sine theta. So I got cosine theta squared plus sine theta squared. I can do some cross canceling. Cosine and the cosine are gone. And if you notice, I have cosine theta squared plus sine theta squared. That's basically a 1. So I have 1 over sine theta times sine theta, which is 1 over sine theta squared. And what is 1 over sine theta? Well, that is cosecant theta squared, which is the right-hand side. That means I got it right. That is number 16. Last thing, some helpful tips to help you to do these identity questions more smoothly. First, you can either start from the left side and prove to get the right side, or you can prove the left side and the right side actually equal the same thing. 2, this is actually the most important step. If you really don't know where to start, always try to change everything into sine or cosine first, and then you can proceed. You will for sure notice something. Next, don't forget, since we're dealing with fractions, a lot of time you are going to have common denominator, or you need to actually get rid of the denominator, or you need to find, or you need to cross multiply or cross cancel. So these are some pretty common things. And last thing, you can already see we have been doing some factoring and distribution. So that's actually going to come back when we do identities. That is everything for 9.12. Thank you.